Let me introduce our speakers for today. I'll be chairing the afternoon and the Q&A session, and also providing a few opening remarks to set the scene for our presentations. My name is Caroline Ray. I am a chartered civil and structural engineer, and I'm the regional director for Arup in East Africa, based in Nairobi, Kenya. I've been working in Southern and Eastern Africa for more than 20 years, having begun my career in the UK, and been championing our work in sustainable development and decarbonisation of the built environment during all of my time here, working both with public sector, with private sector, and sometimes NGOs, both in the formal and informal sectors. We have three amazing speakers for today from the country representing projects and organisations from across the East Africa region. First of all, we have Edson Agume, who is a director and lead civil and structural engineer for Local Works Limited, based in Uganda. He has over 18 years of experience in Uganda's building construction industry, is a member of the Institution of Professional Engineers in Uganda, and a registered engineer. As a co-founder and lead structural engineer for Local Works Limited, he has championed the use of locally sourced materials to deliver high-quality, low-carbon buildings. Edson was key in the development of Eco Prefab, a prefabricated timber frame system using locally sourced FSC certified pine and eucalyptus for the construction of school buildings. His practice is defined by a commitment to pushing the limits of local resources to create buildings for social use. Zani Gichuki is our second speaker, who is a co-founder and chief technical officer for Afinao Mbao, which is a Kenyan-based women-led design and construction company founded in 2023. She is based in Nairobi with over 9 years experience in East and Southern Africa, both in design and construction of projects ranging from housing to education and healthcare sectors. And last but not least, our final speaker is Wekesa George, who is a partner at Studio OMT Architects. Wekesa is a Kenyan architect and passionate advocate for sustainable building materials in East Africa. He has a proven track record of collaborating with socially and environmentally responsible enterprises across the region, with a focus on alternative building materials and environmentally conscious design. His career includes a pivotal experience at Buildex Studio, where his work as a project manager and architect contributed to advancing timber construction, including involvement in Kenya's inaugural mass timber demonstration project. He is now a partner at Studio OMT Architects, a practice dedicated to creating innovative, flexible design solutions based on local practices and resources. So we look forward to hearing their presentations just very shortly. So what are the opportunities for us as engineers, as professionals in the built environment in East Africa? Why are we talking about structural timber? Well, Africa's population is growing rapidly. The current population is estimated to grow, or anticipated to grow, by more than 1 billion by the year 2050, just 25 years away. And it will become the most populous continent on the planet. The urban population is growing more rapidly than the rural, both through population influx from rural areas, but also just the population growth within our current cities. So the urban population is likely to grow by more than 1.4 billion by the year 2050. And East Africa is one of the fastest urbanizing regions globally. That means that many of the buildings, 70 to 80% of the buildings that will be built by 2050, the years that are so important for climate change, currently do not exist. They still have to be built. And that creates an opportunity for us, because we have the opportunity, which doesn't occur in many other places in the world, to be building right first time and not just retrofitting lower carbon solutions later. We have this incredible need for new buildings, particularly new buildings in the housing sector. There was a study we did a few years ago that was looking at the rate of supply of units in the housing sector at the moment, just in Kenya. And the rate needs to more than treble in order to meet the housing demand. We currently have a deficit of more than 2 million units and require more than 12 million units just in housing within Nairobi in the next coming years. We also, alongside the housing, have need for other social infrastructure, for schools, for healthcare facilities, for basic places to work, for our industrialization that's coming. And so the opportunity that we have is huge. But we all understand the figures to do with the carbon footprint of construction. You know, globally, embodied carbon represents about 11% of carbon emissions. But in East Africa, the embodied carbon component of our building's footprint is proportionately higher than it would be in, say, Global North. We generally don't have any heating in our buildings, not unless there are particular specialist facilities. We do sometimes have cooling, but in many of our climates, we can cope with natural ventilation perfectly adequately and don't even have cooling. So our operational carbon footprint is proportionally less than our embodied carbon footprint, which means that our material choices for all of that new construction are fundamental to the overall carbon footprint of our built environment. In Kenya, that disproportionate amount of carbon from our construction sector is very visible. It's currently about a third of our overall emissions. We have a very green energy grid, which helps and helps in other sectors, but it means that our embodied carbon and how we manufacture materials, how we process them and bring them to site is disproportionately larger part of our national contribution or national carbon footprint. That creates a massive opportunity for us as structural engineers to look at how to do things differently. So realistically, is timber an alternative? Are they realistic alternatives? Well, we think they are, but we need to look at the tensions that we have in this transition away from the traditional materials through the modern materials and into bio-based construction being used in a more technical way, perhaps for the higher-rise, denser urban developments. Building regulations across East Africa are fragmented or outdated. Material grading and design standards are quite outdated. And we don't necessarily have clear guidelines on how to use technical timber as opposed to traditional timber that was used in a very basic form. We also have in our education to do with, I would say, modern or technical timber. Engineering education is currently all to do with steel, concrete, and those more, what in inverted commas I would call modern construction materials. But timber has just dropped out of our education syllabus completely. Our universities simply do not teach it. And that means our designers and also our approving authorities are just not familiar with how to use technical timber in a way that is fit for the future. Aren't we going to deplete our forest? Regulated cutting of trees takes place. But no, there was a study that we did a few years ago looking at the current sustainable forest supply, not necessarily certified to FSC certification, but we do have sustainably managed within our region. And that supply, even today, without further planting, far outweighs the demand of what's likely to be used within the construction sector. So really, we don't have a problem with sustainable supply of timber, sustainably managed timber. And another question, which our speakers are going to address, is to do with the material characteristics. Is it durable? What about termites? What about fire resistance? What about perceptions? Because isn't using timber going back in time? Our grandfathers used to live in timber houses. Surely we want something more modern. How do we overcome these perceptions that timber is not a suitable material for our modern construction? Well, our speakers are going to address some of these questions and show how we're already working to solve some of these challenges and improve adoption in the sector in the coming years. We've been referencing some resources which will be available through that resources tab or through the slides which will be shared after the presentation. But now, without any further ado, I'm going to hand over to Edson to give us his presentation based on his experience in Uganda. Thanks, Edson. Over to you.
Thank you, Caroline. Once again, I'm Edson. I'm a structural engineer at LocalWorks, and I'm talking about timber treatment for durability. Most of the rationale for using timber, I think Caroline has really captured it quite well. There's nothing really more I can add in. Just to say that East Africa, it is estimated that is lacking about 200,000 additional classrooms, and the number is growing. And I mean, this statistic was from a few years ago, it's not even from today. And Uganda alone is estimated to be lacking about 80,000 more classrooms. And UNICEF has stated that about 1.6 million of school-going children are actually not going to school. So the problem is overwhelming, and Karen has already stated how the resources are available, literally overflowing, and I'm not going to add anything to it. So, and our solution basically has been is there a way we can build faster? Is there a way we can build better? Is there a way we can build more sustainably? And our answer has been basically to use prefabricated timber-framed systems for building classrooms and associated infrastructure around schools. We call this product eco-prefab. But there's of course a lot of problems that are associated with timber. As you know, timber as a bio-based material, it is subject to attack from insects and also from fungus, which basically causes rotting, which really compromises will compromise the buildings that we build with timber. And a bit brief on how this works is that we have basically rotting that will happen even at very low moisture. I mean, the specifications that show that we build at 12% moisture content. But as you may know, just here in Kampala, our relative humidity is normally between 60 to 80%, and that means that we're going to have the timber moisture content restabilized to about 16%, which makes it susceptible to dry rot. Basically, between 12 to 20%, you'll have dry rot happening. Above 20%, you actually have normal wet rotting that is quite rapid. So our solution to this, of combating this problem, is chemical preservation. using boron salts, but also dealing with the building envelope, the detailing, to make sure that we control the moisture in this timber so that it doesn't get damaged. As to just re-emphasize that even when the timber has been treated, if it is going to be subjected to moisture, especially wetting, that treatment will easily leach out. So, like I've already said, we're using boron salts, basically, which is a combination of borax and boric acid, forming this DOT, disodium octaborate tetrahydrate, which releases the boron into the timber cells. So, and the reason that we basically think boron is a good alternative is because, for starters, it's not very toxic. It's actually comparable to table salt, the toxicity of boron, and yet it's very, very effective when it comes especially to managing rotting, the fungi. Also very effective in managing termites. But are there other alternatives? Of course, there are many other alternatives, especially most of them which are copper-based, which are quite toxic. So that's why we try to avoid them. But boron has a bit of limitations because it actually does not fix itself in the timber. It's a bit mobile, which is a good thing because its mobility helps in ensuring that it actually is effective, even when the full thickness or the full piece of timber has not been saturated with these salts. Even with some moisture, these salts are able to actually migrate and become effective. However, this also means that the ease of leaching out of these salts is quite high. So how are we controlling this, or how are we trying to control this? Basically, creating an envelope or a building envelope that reduces the likelihood of the circulation of the timber, which is basically what you see is we are plastering these buildings, but not with cement plaster, but with lime plaster, which is lime also has very good antifungal properties because of its high pH. But most importantly, it kind of creates this breathable envelope or finish, which kind of allows or protects this timber from wetting, from the humidity or from rain or anything that from the outside, but also allows it to easily expel this moisture if there's any entrapped moisture in this timber. It's also not possible that we can actually encapsulate or basically plaster all the timber. So some of the timber, especially the roof framing, is sealed with linseed oil, also to avoid this issue of leaching. We are also trying to make sure that we avoid as much moisture from the ground. So we get this timber off the ground with a concrete plinth and with a folded galvanized plate, which is kind of it's kind of folded in a C profile, so that the timber sole plate can also easily breathe rather than sitting on one continuous moisture barrier. The timber at the bottom basically is, or towards the outside, we're also trying to use this steel sole plate to ensure that we stop insects, especially termites, from physically climbing up. It's very difficult to see on the image, but yeah, it's kind of a leap over of about 40 millimeters that is quite good in controlling actual access of the termites into the building. We also are trying to build with reasonable roof overhangs, so that we avoid actual direct wetting from the rain, which should also keep the buildings quite dry. Just to recap, yeah, timber durability is actually a design outcome. It's not an inherent material weakness. I think we can actually use timber reliably and reasonably if we treat it well and we detail well. Boron from DOT is a non-toxic treatment choice, which is effective, which is safe, and aligned with green construction methods. Then again, sealing and encapsulation will ensure that we keep this timber, will keep this treatment from leaching out. And like also Caroline had said, East Africa really has a very, very big timber resource that needs to be used. I'm going to hand over to Zani to continue with the presentation. Thank you for listening.
Thank you, Edson. Good afternoon, everyone. My name is Zani, and I'm a structural engineer and a co-founder at Adinambo, which, as the name suggests, provides design and build services in earth and timber. So we're going to discuss timber as a structural material and cover a few topics such as proper seasoning of the timber, visual and structural grading, some common species that are used in construction in the region and their properties, the present and future of testing in the region, and a brief introduction to mass timber. So timber is, as I said, an isotropic. So it's significantly stronger along the grain than it is across it. It has a good strength to weight ratio, with some mass timber buildings being quoted as being a fifth of the weight of typical reinforced concrete construction. And it's also it's a pleasing material to look at. However, moisture, as was previously mentioned, and defects affect the timber performance, which is why timber has to be well seasoned and graded. Seasoning is basically just the drying of the timber, and it can be done with kilns or by air drying. So most structural applications will require the timber to have a moisture content of 12%, as moisture can reduce the strength and stiffness properties of the timber. But the use of the structure and other factors will also determine what your optimum moisture content will be. For example, in the Eurocode Service Class 1 is for enclosed structures such as offices, schools. Service Class 2 is for partially exposed structure, and 3 is for fully exposed structures such as bridges, which could allow you to go up to a 20% moisture content. Visual grading, which would be the next step after before you would use the timber, is sorting the timber according to its physical characteristics that are known to lower its strength. In Kenya, we use a Kenyan standard for grading softwoods, which is based on the British standards. Sorry about that. Yes, that's based on the British standards, and we use the British standard for the visual grading of hardwoods. So the largest predictors of strength would be the number, size, and location of knots and the slope of grain. Knots are areas where the branches grew from the tree, causing points of weakness, and you don't want them at critical points of the beam, like in the middle or at extreme fibers, but the really small ones can be ignored, and all those rules are in the grading rule book. The slope of grain is just the direction of the grain in relation to the length of the timber. So the straighter the grain is, the better the timber will be because it's strong along the grain. Other defects such as decay caused by rot or insect boring, fissures in the timber, and wane and want, which are dimensional tolerance issues, are also measured. And then based on that, they're assigned a grade. So for softwoods, there are 2 grades, which is the general structural and the special structural grade. General structural grade is suitable for applications that have low to moderate loading, while the special structural grades are for high load bearing scenarios. For the tropical hardwoods, there's only one grade, which is just the tropical hardwood grade. Everything else would be marked as a fail. So the visual grading is very important in selecting the good timber, but for efficient engineering design, you would need to have structural grading. So timber is structurally graded according to, in the Eurocode, based on the bending strength of the timber. The other codes, like the Australian one, which rely on the tensile strength, but since in East Africa we're following the Eurocodes, that's also how we're going to name our timber here. So softwoods and hardwoods are graded differently. Softwoods are always start with the letter C, which stands for coniferous, and hardwoods start with the letter D, which stands for deciduous. So, for example, if I were to say a C24 timber, I mean it's a softwood with a bending strength of 24 newtons per millimeter squared. The rest of the properties are taken from the table in the Eurocode, but these correlations have been made based on testing timber in Europe. And there may be different correlations for timber grown in East Africa because it grows much faster than it does in Europe. So we will now look at some common species used in the region. Most of the structural timber in East Africa comes from plantations. So there are large plantations of pine, cypress, and eucalyptus, which would provide a large volume supply, which natural forests would never be able to sustain. So in the list that I'm going to discuss today, the only indigenous species is Melia. The rest are exotic, but they're widely grown in the region. So we'll start with pine. There are a couple of different species of pine in the region, and it's well liked because it's fast growing, has a good strength to weight ratio. There's high availability from FSC certified plantations, meaning that it's sustainably grown and sourced. Typically, from the different tests that have been done on it, it can be anywhere between C14 and C24. It has good workability and nail holding, and it requires treatment for exterior use. The main disadvantage, which is an advantage of timber in general, is it's prone to warping if it's not seasoned properly. Then we have cypress, which is widely available in Kenya. It has better natural durability than pine and good workability. The high availability is mostly just in Kenya. It has not really been graded to Eurocode standards, but for engineering purposes, locally, most people assume it's between C16 and C18. It does grow more knots than pine. Then for the hardwoods, we have eucalyptus, the number of species of that. It's also well liked because it's a fast growing and dense species, and it's also quite widely available. For hardwoods, one of the main things to consider is while doing your connections that you'd have to pre-drill the holes, because attempting to drill the holes directly would cause the timber to split. And eucalyptus is known for splitting, but this can be mitigated if the seasoning is done well. And then we have Melia, which is the only indigenous species on the list. It's highly drought resistant and durable. It grows in arid and semi-arid areas. It's termite resistant, and early testing that we've done on a very small sample size, though, is between D18 and D30. The disadvantages is it's still scaling up in commercial plantation. And the last one is teak, also a hardwood, a high natural resistance to termites and drought, high durability. It's aesthetically pleasing, but it's also quite expensive, slow growing, and you would have to replace your tool parts quite quickly. That would be your saws and drill bits. Next, we will speak about testing. And to use Eurocode 5 confidently, engineers would need defined strength classes. So while there's a lot of testing ongoing at research institutions, it's largely currently driven on a project basis. So individual companies or engineers are testing their own timber, leading to very small and fragmented data sets. A lot of testing in the region is also involving retrofitting old machines that are actually meant for concrete and stone, which could lead to some errors in reading results. but that's the current state of testing. And when it comes to visual grading, most timber suppliers do not grade their timber unless you request them to. And all of this lack of data could lead us to over-engineer our designs, which is wasteful. So locally, engineers conduct their own testing on the timber to determine strength characteristics, ranging from site testing using materials of known weight, as seen on the left, where Mass Design Group, after testing smaller samples in the laboratory, assembled full-size beams and tested them on site. And the images in the middle and on the right are tests that we at Ardhi Nambao have been doing with collaboration with the local university at their timber lab. We've been testing pine and Melia for the fabrication of mass timber, which I'll speak about shortly. So the future of testing involves, one, getting all the timber visually graded properly. Carefree is to resume its training of graders, so that would be great for the industry. Also, looking towards non-destructive testing of timber, because at the moment all the testing that we do destroys the timber, which also discourages people from testing the timber in large quantities. So using non-destructive testing methods such as ultrasound testing, and at the most high-tech level would be to have integrated X-ray and laser scanners at the sawmill to immediately assign a strength class for each piece of timber. On site, there are also handheld tools that can be used, but the caveat for all this is that the machines must still be calibrated with lab testing. So the future can only exist if we have the large-scale testing. A brief introduction to mass timber. For those who are not aware, mass timber is a building system that uses wood bonded together in layers to create strong structural elements. We have glue laminated timber, which is used in beams and columns where all the grains are facing the same direction. Cross-laminated timber, where the grains are in perpendicular directions, giving strength in 2 directions, mostly for slabs, walls, and roofs. And dowel and nail laminated timber are similar to glue lam. It's just that instead of glue, they use dowels and nails. Some examples in the region of timber that has mass timber that's been locally made, and in the case of Mass Design Group used, is teak glue lam. Mass Design Group designed, fabricated, and installed their own glue lam columns and beams. And us at Ardhi Nambao, who are in the process of prototyping and have made our own CLT and glue lam. So in summary, you should know your material, specify the right species based on strength, availability, and use, design for the material, accounting for the specific behavior of the wood, such as if it's hardwood, pre-drilling and treating your softwoods, specify quality, use properly seasoned graded timber and good workmanship to ensure structural integrity, and build for the future. Timber is not just a structural material, it's our opportunity for sustainable low carbon development. Thank you. I'll hand it over to Wekesa.
Thank you, Zani. Second. Okay. So my name is Wekesa George. I'm an architect working in Kenya, currently working as a partner at Studio OMT Architects. So I'm going to talk about designing with timber and looking at a case of Fumba Town, which is one of our flagship timber development in Zanzibar. So that's an aerial view of Fumba Town. With this visual actually incorporates a drone shot and some visuals that we've rendered. So part of it is implemented and part of it is still at the concept stage. This master plan was conceptualized in 2013 and progressively scaled from single-story hybrid timber structures to 4 stories at the moment. And we're also conceptualizing this tall tower that you see here that will be 28 stories. So I'll talk to you about 3 projects in that master plan, which are the ones highlighted here. So we have Cheche, Moyoni, and Vizazi. Cheche, which covers quite an expansive area, is an affordable housing project. So an overview of the timber systems. So when we started back in 2013, we basically just learned by doing. We didn't have as much timber knowledge in how we designed and implemented our projects, and it turns out that surprisingly, we actually were more cost effective and resource efficient by implementing with limited knowledge, as opposed to when we started acquiring more knowledge and wanted to use more timber in the buildings, which actually ended up being value engineered out. So as an overview, we basically most of the structures within that master plan have a conventional ground floor, and then the stories above it are made out of timber. This is for the reasons partly what the previous speakers have highlighted, to do with the protection of the timber from weather, but also we are accommodating different programs in some of the typologies, where we have retail spaces on ground floor in some of the mixed use typologies, and timber for the residential typologies on top. So over the years, we've gone through some iterations of the different timber systems. This has majorly been driven by trying as much as possible to integrate the local timber, and also optimizing on the resource use. So not trying to use timber everywhere, but also just thinking through strategically where is it more efficient to use timber. For example, we realized that the most effective way to use cross-laminated timber is within the flooring system as opposed to the walling systems. So most of the walling systems have been updated, and we're now more or less using a timber frame system similar to the one that the first speaker talked about for the classrooms. The first project we did, the Moyoni Homes, which was the first CLT building in Zanzibar. This building had it was one of the buildings that we did without much knowledge on timber, and surprisingly, we ended up being on cost with the developer, and also it got a lot of market traction, and even in terms of environmental standards, we recently, or last year, we won the Built by Nature prize and got to be shortlisted among the most sustainable buildings in Africa. So the system comprises of the timber frame walls, which on the outside have cement fiber, and on the inside they have an OSB board. So these systems are prefabricated offsite and just assembled as panels on site, and then finished off with a wood fiber infill for insulation, and then a gypsum. The flooring system is a hybrid composite system with the CLT floor. Also, this is one of the iterations that we did earlier when we were using South African timber, which is less dense. So its structural performance is slightly not as strong as some of the timber we got from other places like Europe later on. In how we laid out this building, we made it very flexible so that only a few walls were structural within the apartment, so that the different layouts could be achieved, and the clients could customize the apartment to their liking. We also strategically positioned the wet walls, or the walls that have the bathroom and the kitchen against each other, so that we limit the number of walls that need to do waterproofing, which is actually a very good strategy when you're building with timber. That's the final outcome of that first project, where we had an exposed CLT slab, which formed a really nice and warm ceiling without the need for additional finishes, which often inflate the cost as well. Also, since we were designing building in Zanzibar, we positioned openings strategically so that we could have opportunities for cross ventilation. And we have an added shutter on the outside and some cases on the inside where you can actually close off and limit the heat gain in the building when it's not being occupied. Second building is the Vizazi Homes, which we designed as a multi-generational home. So just building on the flexibility of the previous units, we made it such that this unit could be customized in different layouts, so that eventually, as the family grows and evolves, the use of the apartment could be different. It's a 3-story apartment, so it's a growth from the previous one, which was 2 stories. And we made the bathroom units, which are highlighted in green, as prefabricated elements offsite, and then they were just assembled on site, which actually made the speed of construction really fast, also reducing the waste on site. This building, the client had actually started to learn more about timber. Ourselves, we also started to learn more about timber. So they became more ambitious in trying to use timber everywhere. So they wanted to have a full CLT building, which we quickly realized that is actually not a good decision. First, because of the cost increases, but also using CLT everywhere requires a lot of volume of timber, which can be wasted if not used efficiently. So in the next iteration of that building, what we did is we changed some of the CLT elements, especially for the walls, into timber frame walls. We only limited the CLT to the floors and some of the signature architectural elements, such as the staircases within the apartment. This actually resulted in almost a third of the costs being reduced from the building and making it even more viable. So that's a view of the first apartment, which we did all full CLT. We still retained this signature staircase, which we quite liked in terms of a design outcome. So that's also something that is really appealing to the buyers when they visit the apartment. That's the look of the building from the exterior, the first building that we did. It really was built very fast compared to some of the other ones at the back here that were built with masonry and concrete, which took a significant amount of time to finish when we had already plastered and were done and moving on to the next typology. So it actually goes to show how fast we can build with timber, and it's actually really saves a lot on the developer's side things. So the success of those 2 projects, which were a bit on the higher end market side, allowed us to build confidence in the social acceptance of the material as being aspirational enough to be used in affordable housing. So the fact that we could demonstrate that people are willing to spend more in the higher end markets, we were able to also show that this is not just a cheap material that would then be used in an affordable housing setting. So that actually built a lot of confidence in building this affordable housing design. And we also took this opportunity to infuse some of the local traditions within Zanzibar. So timber is also a material that has been used traditionally within Zanzibar's stone town. And it's something we wanted to celebrate also as a way of connecting modern interpretations of the material to what had been done in the past. So we borrowed some of the elements in terms of how we express the portico spaces on the exterior of the building, which are quite similar to how you've seen the traditional architecture. This is a 4-story typology. So also a progression in terms of density from the previous typology, which was 3 stories. And in this project, we also did some value engineering exercises just to make it viable for the market. One being the reduction of the CLT walls and using timber frame walls instead. Also, one thing we did was switch from a composite CLT slab, so CLT and reinforced concrete, into a CLT slab with just a concrete topping to increase the mass. This was made possible because we also switched from different supplies of timber. So initially we were using South African timber, which is less dense, and also in terms of the structural performance, it required that reinforcement layer on top of the concrete to make it viable, as opposed to the other system, which with the European spruce, which we used, it actually made it easy to implement just a timber system that doesn't need as much concrete. All these structures have been made in compliance with international fire and life safety regulations, which was a combination of both Swiss and British regulations in how we size the building, also how we, like the length of this building, for example, is actually at the limit of the maximum travel distance you can go. And all the fire compartmentalizations was also done accordingly. So you can see the red marking where we have the 60-minute fire rating walls, and then the inside partitions had a lesser rating because we made them as flexible partition systems. And then one other thing we did in terms of the value addition also was switching between smaller members of the CLT into a more unified member, which allowed for ease of transport and assembly logistics on site. In terms of the detailing, we also simplified it over time from CLT walls to the timber frame walls. Also, initially when we were using less dense wood, we needed to increase the charring depth by adding additional members at the corners, as you can see in the detail on the left. So making it a bit more bulky. But then when we used more durable wood on the right, we were able to simplify these details, and also did not need to use the reinforced concrete layer on top that I've explained before. So the construction was quite fast. The 3 levels above the conventional built floor below were actually done in 1 week, which is quite impressive. And that's the finished building on the right. And you can also see how the construction site is quite clean, the minimal waste, not very typical of most of the construction sites that we see here in East Africa. So in conclusion, we tried as much as possible to incorporate a lot of locally sourced wood, as much as, yes, we had to still import some of the wood elements to make the projects viable. Our goal is to use all these systems to show that it's a thing that can work in East Africa, so that we start off first by using simple applications of locally sourced wood, as we also gear up for a market that is more related to manufacturing and locally sourced wood. Thank you for listening. I'll hand it over back to Caroline.
Great, thank you so much, Wekesa, and thank you to all of our speakers. Really fascinating inputs and everything, and I can tell from all the questions that are flowing in, it's generated a lot of interest amongst our audience. So thank you very much for listening. We're going to handle some Q&A as much as we can in the time that's available. I'm not sure if we'll get to everything. And if I can throw the first couple of questions in Zani's direction, please. There was a specific question to do with the grading that you were talking about, and which universities are involved in the grading and sort of testing of materials that you were referring to. But then if I could ask a related question, in general, in terms of increasing adoption in the East Africa construction sector, what would you say are the highest priority actions over the coming few years? What would you want to see actioned next?
For the first question, the university that we partnered with was the University of Nairobi, who had, they have a timber lab and some new equipment, so we were all testing it out together. And for the second question, I think the things that would propel the industry the furthest would be, as I keep harping on about the grading, so that we can know what we're working with. The training of students, but also professionals and the people who are going to do the inspections, that would go a long way. And the work, I guess, Arab is doing to try and come up with some standardized uses of the timber just to begin with, before people build confidence, I think would be the immediate first steps.
Great, thank you. And a couple of questions for Edson. There was a question to do with the sheathing materials for the timber that you're referring to, that you're using in the classrooms. I wonder if you could just explain a bit more about that.
Yes, the sheathing material, I hope we mean encapsulation materials. So we are using a lime-based plaster, which is basically lime with sand, with a bit of cement, so that you get some initial strength to ensure a bit of easy curing. And then we are also finishing it up with a lime finish, which is basically a lime paste kind of finish. And the reason for this, like I'd said, is basically to ensure a breathable environment, so that you don't have any kind of buildup of moisture inside this system. Then for exposed timber, exposed but covered from weather is just basic linseed oil sealant. Yeah.
Okay, great, thank you. And a couple of questions for Wekesa, please. Firstly is to do with thermal mass and how these timber or hybrid construction using some timber, how those buildings are performing in relation to thermal comfort as they have a lower thermal mass in what's our hot environment. If you could explain that, but also perhaps say a little bit about how you've been beginning to move away from imported timber to locally sourced and locally manufactured. Thanks.
Okay, thank you. So I'll start with the second question on how we've been moving away from imported timber. So our initial strategy was to use South African pine, which is quite a similar species that's growing in the southern highlands of Tanzania. And by us understanding how to design with it, we were hoping that by the time the manufacturing was able to be done in Tanzania, we could use the same sort of strategies we implemented from learning from those learnings. So that was one strategy we initially used. Yes, we are still not yet there at the manufacturing in Tanzania, but we hope that gets there. The second thing is beyond using engineered timber, we tried very simple applications of what is already existing of the timber supply from the mainland Tanzania into Zanzibar. So this included the applications we were showing on the timber frame systems for those framing systems, which came from locally sourced timber within Tanzania. So that is one of the simple applications we are trying to do to sort of infuse some of the local timber as the market builds with all the grading, all the sizing, and all these other standards meeting it at some point. In terms of the thermal mass, so from what we get in terms of feedback from occupants in these buildings, they actually have no issue with heat gain in the buildings because first of all, in the full CLT timber buildings, timber is inherently a very good insulator. So you don't necessarily need a huge mass to sort of provide the same insulation compared to a different systems such as concrete or steel. So that first layer also ensures that you have the thermal comfort inside the building. And the second is, as architects also, we try to make a lot of cross ventilation possible within that climate so that the building is quite airy, and that helps with cooling the building. I hope that answers.
That's great. Thank you so much. I'm afraid we don't have time for answering all of the questions, although we'll see what we can do answering them in the chat afterwards. But thank you so much for joining. I hope that you have seen that we don't have an option of doing nothing. Sometimes when we talk about the the built environment and decarbonisation and being involved in climate action, we say, well, we just shouldn't build anything. You know, we should build as little as possible. For us in Africa, that's not an option. We have more than 1 billion more people who are going to be needing housing and basic services and infrastructure. So build nothing, do nothing is not an option. We have to do things differently. And I hope that you have seen as well through our presentations that those of us working in the East Africa region are already doing whatever we can in order to enhance the role and support the inclusion of structural timber as a bio-based construction material within our region. We're very much working as a collective. We're working to support our governments, bringing in technical expertise where we can, and making sure that we as structural engineers within the region are doing whatever we can in respect of this and climate action.